This video is going to cover the topic of dividing integers. Be sure the date and topic are at the top of your page. The essential question for this video is how do we use fact families to help us to divide integers? And to answer that question, we are first going to talk about fact families. From our work with math in our younger years, we should know that there are fact families of multiplication and division. And of course, those fact families are groups of numbers that are related to one another, and they can be combined in different combinations to make a series of number sentences. And those number sentences that we can make are made with inverse operations. And inverse operations are just a fancy way of expressing opposite operations, like multiplying is the opposite or inverse of dividing. So for example, if I have this fact family, 4 times 5 equals 20, I can also rewrite the numbers in this family as 5 times 4 equals 20. Or using the inverse operation, using division, we can also write 20 divided by 5 equals 4. Or even more, we could do 20 divided by 4 equals 5. So here's an example of a fact family, and we have these two inverse operations that we're seeing within this family. And using fact families will help us make a rule for dividing integers. So let's look at the following numbers here. We have 4 times negative 3, and we know that, of course, would be a negative 12. So I'm going to put that in there. So as we know that 4 times 3 is 12, but a positive times a negative would get us a negative. Because of our fact families and because we know about the commutative property, we know that that means that also negative 3 times 4 will give us that negative 12, right? That will result in the same thing. But what if we want to divide, right? I know that if I divide negative 12, by one of these factors, I should get the other. So that must mean that negative 12 divided by, let's start with 4, divided by one of the factors, has to be the other factor. And the other factor is negative 3. So negative 12 divided by 4 must be negative 3. We also know that negative 12 divided by negative 3, if those were the numbers I was looking at, let me put parentheses here. If I was dividing negative 12 by the negative 3, I have to get the other member of that family, which was 4. So that negative 12 divided by negative 3 has to be a positive 4. Here's another example, right? Negative 5 times a negative 2. I know 5 times 2 is 10. And then let's see, so I have a negative times a negative. That means it's a positive, right? So this will be a positive 10. We also know then that if I reorder these multiplication numbers here, my factors, if I do a negative 2 times negative 5, that will also get me that positive 10. Right? And that means we know something about that division, right? What if we want to divide? Well, I know that if I divide 10 by one of my factors, let's say I use the negative 5, I have to get the other. So my answer has to be a negative 2. So my 10 divided by a negative 5 is a negative 2. I also know that if I start with 10 and I want to divide it by the other factor, negative 2, I'll get the remaining negative 5. So 10 divided by negative 2 has to be a negative 5. We'll look at a few more examples and we'll see if we can make some patterns or notice some patterns that we can help to make a rule. So I just made a quick table here so we can look at some observations and notice some patterns. And you can go ahead and make a quick copy of this in your spiral as well. I'm just going to show a couple examples of some number sentences and their related fact families, and then we'll see what kind of patterns we notice. We'll start here with a 6 times negative 5, which would be a negative 30. And we know that if we were to divide and use our fact family in a different operation, we would do negative 30 divided by the 6 would have to leave us with the negative 5. So right away I see that if I have a negative and I'm dividing it by a positive, the result is negative. Let's look at another fact family. So now I have a negative 7 times a positive 4, which of course is a negative 28. And I'm going to rearrange that into its inverse operation using division instead, which would result in a negative 28 being divided by a negative 7 and getting a quotient of a positive 4. Right? That would be the combination with that back family. So this time it looks like I divided a negative by a negative, but the quotient, the result, was positive. So I'll jot that down next. In our last example, we have a negative 3 times a negative 8, and that of course ends up being a positive 24. So I'm going to rewrite that, right, with the inverse operation, dividing the 24 by one of my factors to get the other. And that would leave us, of course, with a positive 24 being divided by a negative 3 and getting a negative 8. So it looks like when I had a positive number and I divided it by a negative, the quotient was negative. And those seem to make sense based on what we know about multiplication, where if we have two of the same sign, the result is positive, and if we have one of each, an odd number, right, of negatives, the result still remains negative. That seems to match here, which makes sense since these are fact families. And multiplication are just inverse operations, right? They're part of the same fact family. And this video was the goal, the essential question of this video was to highlight how these fact families can help us divide integers. And so hopefully you can see that there are some rules that we might be able to start using as we practice in class. In addition to your notes and any questions you might have, go ahead and try these 3 quick problems, right, and see what your quotient, what your result is. Think about what we know about what has to be the missing piece of this family, and think very carefully about whether it is a positive or negative integer when you get to your answer.